Picture a 30-year-old residential building. A renovation commission arrives at your design firm. Under the traditional workflow, structural review alone takes 2 full weeks. A preliminary drawing set takes another week on top of that. Preparing permit documentation adds yet another week. The entire process routinely exceeds a month, and on complex projects, far longer. But right now, in leading design offices around the world, that entire pipeline is being completed in under 3 days. AI reads the structure, assesses the risks, and generates the drawings. Automation is arriving at the most fundamental domain of architectural practice. Today, we look directly at what that wave actually means and what it means for you. Let us first establish why renovation design specifically is the frontier where AI is having its greatest impact. The scale of the challenge is staggering, and it is not limited to any single country. In Korea, government data shows that as of 2024, nearly 1.9 million buildings have surpassed the 30-year mark. But Korea is far from alone. Across Europe, North America, and East Asia, aging building stock has become one of the defining infrastructure challenges of the decade. New construction permit volumes are declining in most mature markets, while the global renovation and refurbishment sector is growing at over 7% per year and accelerating. The critical issue, however, is not scale. It is complexity. Renovation is inherently harder than new construction. You must understand the existing structural condition from the ground up, anticipate hidden defects concealed behind decades of finishes, and define precisely, in legally defensible terms, what can be changed and what cannot. It is precisely this layered complexity that makes AI far more transformative in renovation work than in new builds. Let us look at how AI-based structural safety assessment works in real-world practice today. The process breaks down into 3 distinct stages. The first is data collection. LiDAR scanners and drone-mounted cameras capture the entire building in 3 dimensions, generating millions of individual data points, a precise point cloud that becomes a digital twin of the physical structure. The second stage is AI analysis. That captured data is then compared against the original structural drawings, applicable building codes, and reference libraries of tens of thousands of comparable structures. The AI model automatically detects crack patterns, exposed rebar, and signs of concrete carbonation, then calculates a risk classification for every identified issue, prioritized by severity and location. The third stage is automated report generation. Diagnoses results are formatted automatically to satisfy regulatory and legal requirements, with no manual templating needed. Work that once required 2 weeks of intensive review by a senior structural engineer is compressed into a matter of hours. Industry research suggests AI crack detection accuracy reaches approximately 94% under controlled conditions, significantly above the 67% typical of unaided visual inspection. Now we reach the core of the workflow. Once structural diagnosis is complete, AI moves directly into design proposal mode. Here is the AI-assisted drawing generation process as validated in real-world practice today, step by step. Stage 1 is spatial recognition. Point cloud data from the 3D scan is processed to automatically classify walls, columns, beams, and slabs. Then converted into BIM objects, the building is digitally reconstructed before a single design decision is made. Stage 2 is constraint filtering. The AI automatically applies the full stack of regulatory constraints, building code limits on structural modifications, unit boundary lines, daylighting and ventilation standards, filtering out any design move that would be legally non-compliant. Global regulatory frameworks are already pushing this capability forward. The UK now mandates BIM Level 2 or above for all publicly procured buildings. And Singapore's Cornet X automated permitting system, the most advanced of its kind, reduced average permit processing time by approximately 60%. With pilot testing showing AI flagging roughly 92% of compliance errors before formal submission. Stage 3 is alternative generation. Within the defined constraints, AI generates dozens of floor plan alternatives almost instantly, with space efficiency, circulation logic, and daylighting simulation all applied simultaneously. Stage 4 is drawing and document output. The selected design is immediately exported as CAD or BIM files, with window schedules, finish material lists, and permit documentation generated automatically alongside. So which tools can your firm actually put into practice right now? Let us compare the AI platforms gaining the most traction in architectural practice worldwide. The first category is generative AI design platforms. Tools such as Xcool embed regulatory code databases directly and automatically generate code-compliant floor plan alternatives based on your project parameters, without requiring manual constraint input for each iteration. The second category is environmental performance platforms. Autodesk Forma, built on a BIM foundation, delivers real-time AI analysis of solar access, wind patterns, and embodied carbon from the earliest design stage, closing the loop between form and environmental performance before construction documents are ever produced. The third category is structural analysis AI. Global engineering platforms such as RISA-3D and ETABS are increasingly integrating AI modules that automatically calculate the load capacity limits of existing structural elements, directly informing how far a renovation can push the original frame without costly interventions. In terms of cost, professional subscriptions to tools in these categories typically range from around $200 to $1,000 per month. Compared with the cost of outsourcing specialist assessment work on a per-project basis, firms handling 3 or more renovation projects per month generally reach break-even almost immediately and compound savings rapidly from that point. The critical question now is, how should your firm actually implement AI and in what sequence? Rushing straight to full-scale adoption can create more disruption than efficiency gain, as a number of early movers have discovered. Here is a phased strategy, validated by real-world practice. Phase 1 is diagnostic support. For the first 1 to 2 months, use AI exclusively as a structural assessment aid. Run it in parallel with your existing workflow, and directly compare its outputs against your engineers' judgments. This is about building verified trust, not replacing expertise. Phase 2 is draft generation delegation. Once that trust is established, delegate initial floor plan generation to AI. The designer's role shifts from originating layouts from scratch to refining, editing, and elevating what the AI proposes. This transition typically unfolds across months 3 and 4. Phase 3 is full workflow integration. AI is then connected to your BIM environment, cost estimation systems, and permit documentation workflows, automating the full pipeline from initial diagnoses through to regulatory submission. Firms that follow this 3-phase approach consistently report design productivity more than doubling within 6 months of beginning the transition. The phasing matters. It is what turns a disruptive technology into a reliable competitive advantage. In an era where AI reads structures, generates drawings, and assembles permit documentation, every architect and interior designer must confront the same question: what is our role? When you look at it clearly, the answer is unambiguous. It is the work I cannot do, reading context, understanding the way a client actually inhabits their space, designing the relationship between a building and its surrounding community, making judgments about beauty, atmosphere, and meaning that have not yet been encoded in any dataset. This work remains, and will remain for a long time, a distinctly human domain. AI raises the speed and precision of design. It compresses timelines and eliminates entire categories of repetitive work. But the direction of design, its purpose, its values, its meaning, is still determined by people. As AI tools become standard in architectural practice worldwide, the question is no longer whether to adopt them. It is how to use them to amplify what only a human architect can bring to a project. Which part of your design workflow would you transform with AI first?